How are you, my friends? This is lecture number 13 of the Calculus 1 lectures, implicit differentiation. Now, in the objectives of this lecture, we will find the derivatives of equations written implicitly. I will explain what is the meaning of implicit in a few minutes. Finding tangent and normal lines to those graphs, and we will solve more related rates problems. Now, in this slide, you will see the meaning, the difference between explicit and implicit. Functions written or expressed explicitly. That means we can write y as a function of x so easily. That's a function. Like this example, y equals x cubed sine of x, etc. This is a polynomial. F of x is equal x plus ln of x. So these are easy to differentiate. We have done before. These are new and little difficult equations expressed implicitly. Let me explain the first and second. X squared plus y squared is equal to 1. So we cannot write here y easily as a function of x. This one is more difficult. Second one, you can see y cubed is equal 4 minus cosine of xy. More difficult, you see. And this is more and more difficult to express y in terms of x, but we can still find the derivative, dy over dx. This is the first example. Use implicit differentiation on the equation x squared plus y squared is equal to 1 to find the derivative dy over dx. Still, dy over dx is y prime. It represents the slope of the tangent line at a given point. Now let's look at example 1 solution. We have x squared plus y squared is equal to 1. This is not a function. To find the derivative, we take the derivative on the left is equal to the derivative on the right. Now the derivative of x squared will be 2x. This is important here, the derivative of y squared, and we know y is a function of x. So it will be 2y times y prime, or we write 2y times dy over dx. You can write either way. Equal the derivative of the 1 is 0. Now rearrange it, take 2x on the other side, and then divide by 2 here. So we get dy over dx, which is y prime, the derivative, minus x over y. Let's take more higher example. X cubed plus y cubed is equal to 3xy. Use implicit differentiation to find the derivative dy over dx. Just be careful here. Okay, take the derivative of both sides. So the derivative of this plus this is equal to the derivative of 3xy. First one, we use power rule, normal. The derivative of x cubed, 3x squared, finished. Now this is the chain rule, y cubed. It will be 3y squared times y prime. You can write always y prime as dy over dx. Because it's easier to write y prime, that's why I put it here. Then at the end, I will write dy over dx. This is the chain rule. On the right side, we have a product. Look here, 3xy. 3 is constant, so I leave it outside. Inside xy, I use u prime v plus v prime u. Remember the rule for product rule. So on the right side, the derivative of x here, see x prime is 1, y times y prime is only y prime times the x. Now divide by 3 here, rearrange it. 3x squared plus 3y squared y prime is equal 3y plus 3y prime x. Divide by 3 the whole equation just to make it simple. You get x squared plus y squared y prime is equal y plus y prime x. Rearrange it. Rearrange it means put all y primes on one side here. See y squared y prime minus y prime x. Take this on the other side, becomes y minus x squared. Take y prime as a common factor. And you can write y prime as also, as I said, dy over dx. Then you divide by this quantity. the derivative becomes y minus x squared divided by y squared minus x. That is the derivative. Now, this is a nice question, actually. We need to find the equation of the tangent line to the graph of this equation, not easy equation, sine x plus 2y is equal to 2x cosine y at the origin. So we have the point 0, 0. We need the tangent line to this graph. For sure, we have to look for the derivative. Use implicit differentiation to find the slope, which is the derivative. So let's go slowly now. Take the derivative on the left here is equal to the derivative on the right. This one, there is a chain rule. So the derivative of sine of u, this is u, it will be cosine of the same u, x plus 2y times the derivative inside. Derivative of x is 1. 2y, the derivative will be 2y prime is equal to 2, leave it outside. We have mentioned in the previous example, this is also a product, x cosine y. The derivative of the x times cosine y plus the derivative of the cosine y times the x. Just go slowly here. Derivative of x is 1, so this becomes cosine y. Derivative of cosine y will be minus sine y times y prime times the x. Now, let m be the slope of the tangent line. Slope, now you can take y prime, replace x equals 0, y 0, because this is the origin, remember? If we have a different point, different values of x, different values of y, then we can replace them like 1, minus 1, 2, 3, 7, half, etc. Y prime means dy over dx at x equals 0, y 0, which is the origin. So I can replace every x by 0, every y by 0, only in this question because we have the origin. So cosine 0 plus 2, 0, cosine of 0, 1 plus 2, m, y prime is m, remember. 2 here, cosine of y 0, minus sine of 0, y prime is m, times x is 0. So this is all 0 here. Cosine of the 0 is 1, so that's 2 on the right side. Cosine of the 0 is 1, 1 times 1 plus 2m. So 1 plus 2m is equal to, take 1 on the other side, m will be half. Finally, we get this slope. Equation of the tangent line, please continue on the next slide. So from the last slide, we have seen slope is half. The point of tangency is 0, 0, which is x1, y1. Let's use the equation of the line formula. Y minus y1 is equal mx minus x1 from algebra course. To find the equation of the tangent line, put all these values. M is half, x1, y1, so you get y equals half x. This is the equation of the tangent line. Now let's take here, given the equation, x squared minus xy plus y squared is equal to 7. Find the equation of the tangent line to the curve at the point minus 1, 2. See, this is x1, y1 now, different from 0, 0. Find the equation of the normal line at the same point. On the solution of example 4, we need to find the slope first, which is the derivative. Here we cannot solve for y, so we use implicit differentiation. So this is the equation x squared minus xy plus y squared. In the y squared, we use the chain rule. In the xy, we use the product rule, and x squared is easy by power rule. So let's find the derivative. 2x minus, this is x dy over dx plus y, just the product rule. This is 2y y prime is equal to 0. Rearrange the equation minus, and this is a minus y. Leave the terms that have dy over dx. Take a common factor. Take y on the other side, 2x on the other side, and then dy over dx will be y minus 2x divided by 2y minus x. Now you need m, the slope. X is minus 1 given, and y is 2. So I replace here x and y. I get 4 over 5. That is the slope. Now, I need the tangent line. I need the normal line. So I have found the slope, 4 over 5, from the previous slide. This is the equation, y minus y1 is equal mx minus x1. So that's easy to use. We know this point here, x1, y1, put it there, you get the equation of the tangent line if you get the slope 4/5. Now the normal line, the slope will be minus 5/4 because the product of the slopes is -1. So use the same equation, y minus y1 is equal mx minus x1, the same point, but the slope is -5/4. So we get the equation of the normal line. Now let's look at some related rates problems. We have seen it before. We take more examples here. The width of a rectangle is half the length, its length. At what rate is its area increasing if its width is 10 centimeters and is increasing at a rate of 0.5 centimeters per second? So we have a rectangle first. Let's understand the question. We have a rectangle that has length and width. It says the width is half the length, so W is equal L over 2. Let's call the length here W, L, and the width is W. dW over dt, the rate of change of the width is 0.5. We know the area, you multiply the width times the length. The length now, if you cross multiply here, it will be 2W. So now we get the area, 2W squared. See, that's a function now. What do we need? The rate of change of the area with respect to time. Let's use the chain rule. dA over dt is equal dA over dW times dW over dt, because W is changing also by time. dA over dt we need, dA over dW, find the derivative here for W, times dW over dt, which is given 0.5, which is half. At W equals 10, so put 4 times 10 times half will be dA over dt 20 centimeter per second. Another nice question. We have a man 6 feet tall. Okay, this is a man here. Walks a speed of 8 feet per second away from a street light. So there is a street light here. 18 feet pole. This is 18 feet, the height. How fast, we need the speed here. How fast is the tip of his shadow moving along the ground? How fast the shadow is moving along the ground. Okay. Let's make more in the diagram here. We have the man, we have the pole. Let Z be the distance between the light. See, this is the Z here. And the end of the shadow. This is all Z. Let's call it Z. Let X be the distance between the light pole and the man. So this is X. So now the shadow is what? Z minus X. Okay, this is what we need. Let's take now similar triangles. So we make the small triangle here, and this is a big triangle there. And we make the ratio Z in the big triangle divided by 18, that's the ratio, equals Z minus X divided by the 6 here. That's the ratio in the similar triangles. Cross multiply, 18Z minus 18X is equal 8Z. Take 6Z on the other side and take 18 on the other side. You will get 2Z is equal 3X. So we have a function Z of X is equal 3 over 2X. That's a function Z. Now by the chain rule, what do we have here? We need dz over dt. dz over dt will be dz over dx times dx over dt. So dz over dt will be dz over dx, 3 over 2. That's the derivative here. And dx over dt is 8. It's given speed. So 3 over 2 times 8 will be 12 feet per second. Always please check the playlist Calculus 1 Solved Questions for more questions to understand the lectures better. This is the end of lecture 13. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video, another topic. Thank you guys for listening.